listen to me, then one of you can raise his or her hand so that I can understand that I'm now audible, and then I'm going to, yeah, okay, fine. Then I'm going to start the session once again afresh. This time I'm going to start the session with a discussion of a problem. Okay, no more theories. Let's discuss with a problem. I am going to calculate correlation. I am going to calculate correlation between two variables. Okay. Now, suppose we have two variables, capital X and capital Y. And for the sake of our problem, let us select a small amount of number, a small quantity of number in them. Say, for example, I am taking the numbers like this. X is equal to, X is taking the numbers 1, 2, 3, 4. For the simplicity of the problem, let us take these points in the following manner. Okay. And suppose I am considering Y to be 2, 4, 6, and 8. Okay. Or you can, it would be nice if I take it in the following way. Let us take it in the following way. 3, 4, and let us take it to be 5, and let us take it to be 6. Okay, these are my numbers, these are my values, capital X and capital Y. Capital X is 1, capital Y equals to 3, capital X is 2, capital Y is 4, capital X is 3, capital Y is 5, and capital X is 4, and capital Y is 6. I am now going to find the correlation between the two variables, capital X and capital Y. In the previous session, I tried to show you I tried to discuss the formula first. And for this, actually, the system also didn't want me to discuss much of the formula. And therefore, it would be nice if I start afresh with a problem. Then gradually, I'm going to get into the formula. If I do not discuss, the system knows that the BBA students wants problem and not the formula. So let us discuss a problem, let us solve it. And later, at the end of the problem, I'm going to talk about the formula. I'm going to show you the formula. Okay, so it would be a nice approach. So I want to find the correlation between the two variables, capital X and capital Y, and this the notation for this, you know, would be RXY, because or sometimes we write it as R. In suffix we write capital X and capital Y, and we know that correlation actually talks about how the variable capital X changes with the variable, with respect to the variable capital Y. That means if capital Y is actually increasing, whether capital X will increase or decrease. Or this is the scenario, or vice versa, or sometimes we call it as, sometimes we say that if capital XY is increasing, what will be the change in the variable capital Y? Okay, so whether it will be increasing or decreasing, these are the scenarios I am writing over here. Similarly, we can study what will be the change in X when capital Y is decreasing, whether capital X is increasing or decreasing. Or sometimes we can study with capital X, if capital X is decreasing, what will be the change in the variable capital Y, whether increasing or decreasing. These are the scenarios, these are the 4 cases which needs to be discussed. Okay, so I am going to find how this variable capital Y with these values 3, 4, 5, 6 is changing with respect to the variable capital X. Here the variables are actually not defined. We do not know what actually capital X and capital Y mean. But here I am going to give you the technical details only, how to calculate the correlation by manual calculations. Okay. But if it is a question of statistics, we shall not be dealing with this amount of data only. We'll be having a huge amount of data, and for this we need to use the software. But every software, as you know, it actually built upon some algorithm of the solution process. But if you do not know the solution process, you will not be able to understand how the algorithm works. And for this, you have to know what the actual algorithm is, and then you are free to use any software. Okay. So in the next page, I'm going to show you how to calculate the correlation between capital X and capital Y. Okay. And you know that if R, this is the sometimes the correlation between the two variables is denoted by R, simple R only. Okay. So if R is greater than 0, if the value of the R is greater than 0, we say X and Y are positively correlated. Positively correlated. Okay. That means if capital X is increasing, capital Y is also increasing. Capital X is decreasing, capital Y is also decreasing. And if R is less than 0, we say that capital X and capital Y are negatively correlated. Negatively correlated. Okay. So this means that if one is increasing, the other is decreasing, or if capital X is decreasing, the Y is increasing. So this is what we know we mean by negative correlation. So this thing is very important. You quickly note it down. We have to check whether R is greater than 0 or whether R is less than 0. We have to calculate for our current problem. And when R is equal to 0, that case means that there is no correlation. There is no correlation between the two variables. There is no correlation between the two variables. Okay. So I'm going to calculate this particular problem now. So let us write the table once again. Capital X having the values 1, 2, 3, and 4. Capital Y is having the value 2. No, what was the value? Let me check. Yeah, 3. It was 3. Sorry. So the value of Y corresponding to the value capital X equal to 1 was 3. That was 4. That was 5. And that was 6. Now the correlation RXY or R is defined by the following formula. Covariance of XY divided by sigma X into sigma Y. So how many terms are there? I have to calculate this term, and that term. So 3 terms are there. I'm going to individually calculate each of these terms. Whenever we do the statistical calculations, we need to construct the table, and we have to know how many columns and how many rows should be there. But that entirely depends upon what is given in the formula. If according to the requirement of the formula, we decide which column we are going to make and how many items we are going to place. To start with, we have to verify, we have to make sure of the fact that capital X and capital Y must contain same number of items. That means this is a very important criteria. I showed you in one of my previous classes that this should be always same. And here you see the number of items is 4 for both capital X and capital Y. So here actually n is equal to 4. This should be equal always. Now the covariance of XY is actually given by the following formula: 1 by n summation capital X Y minus X bar and Y bar. Okay. And this what does it actually mean? We take the two items together, capital X and capital Y, and we take their product. We take their product and we take the sum of these quantities. Okay. So if you want to write the subscript, you can also write it in the following way: 1 by n summation I goes from 1 to n, because the summation is going to be taken over n items, xi and yi. This should be written. Then this will be more specific. And x bar and y bar. What is x bar and y bar? What are they? X bar is the arithmetic mean. It stands for arithmetic mean. The other teacher is going to make you learn this topic, arithmetic mean. That means we take the items of x and we find the summation, and then we divide the sum by the total number of items. That is called the arithmetic mean. In short, it is written in the following way: 1 by n, I goes from 1 to n summation xi. And similarly, the arithmetic mean of the quantity of the variable y is written as 1 by n y1 plus y2 plus dot 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 plus yn. And I'm going to write it in a shorter way, which is 1 by n summation I goes from 1 to n yi. So these are the formula. These are the things which I'm going to implement. This is one thing that is going to be implemented in the respective columns. First of all, my job is to find the covariance xy. So I'm going to make one chart to calculate this particular quantity. After that, I'll come into this section. Let me calculate the numerator part first of all. This is the numerator part, and then I'm going to calculate the denominator part. Okay, so I hope that you have copied this particular board work. If not, then I'll again revisit to this following. I will fluctuate between the screens, and you be ready to take a note of that. Okay, so let me make the chart now for the sake of the calculation. So we have 1, 2, 3, 4, and the values are this. And you see, to calculate the covariance, we have to take the sum of this quantity, sum of this product. That means what? We have to implement one column extra, that is xy. Xy column means I'm going to multiply the values of x by the corresponding values of y. So 1 into 3 gives you 3, 2 into 4 gives you 8, 3 into 5 gives you 15, and 4 into 6 gives you 24. So I have calculated all this. Okay, now let us go back to the previous chart. We have to take the sum of this product. The product which has been calculated, we are going to take the sum of these two, these values. So I am going to take the total, and this total here is this total is actually required in the formula. So we have 8 plus 5 13 plus 4 17 plus 3 20, that is 0, 2 plus 1 3 plus 2, that is 5 50. So the sum total of summation xy is equal to 50. And summation x, because I need to know what summation x is, because if I do not know what summation x, then I will not be able to calculate x bar. So for this, I'm going to add these numbers. So these will be 4 plus 3, that is 7, plus 2, that is 9, and then 1, that is 10. So we have summation x. And summation y is also needed. So we are going to calculate this summation also. So that is 6 plus 4 10 plus 5 15 plus 3 18. All the summations have been calculated. Okay, we are now going to calculate we are now going to calculate x bar first of all. What was x bar? X bar is the, let me go back to the previous screen. X bar is the arithmetic mean of the variables, of the values of the variable capital X. How many variables have been considered here? Small n number of variables. How many variables we have in the problem? We have 4 variables. The value of the variable, number of variable is here is equal to 4. 4 for all the columns. So here n is equal to 4 actually. So your x bar will be 1 by 4. X bar will be 1 by 4, 1 plus 2 plus 3 plus 4. That means, that actually means this is your x1, this is your x2, this is your x3, and this is your x4. I'm writing it for the betterment of your understanding. So I have to look for my calculator. Yeah, here it is. So you see, so I'm going to calculate the thing, and so we have 4 plus 3, that is 7, plus 2, that is the summation which has already been calculated, it is 10. So we have 4 into 1 by 4 into 10, and that is equal to 10 by 4. I mean, that is 2.5. The value is 2.5. Okay. Someone, Dipanjan Ganguly, has raised his hand. Want to say something? Write in the chat box. Chat box is open now. Write it in the chat box. Similarly, if you want to calculate y bar, then you can apply the similar approach, which is 1 by 4. Let me see what Dipanjan is saying. Once more, please. Okay, Dipanjan. Sure. I'm going to talk. See, Dipanjan, you are asking me to say this once more. I'm going to calculate y bar. I'm going to calculate the arithmetic mean of y. You listen to that particular point properly, because because the approach which I'm going to use over here, the same approach has been used for calculating the arithmetic mean x bar. Okay. So what I have I have written over here, please look into that. Capital Y bar is the arithmetic mean of how many points? Small n number of points. I'm saying, Anushka Datta, I'm saying how n is equal to 4. So capital N, what is the formula for arithmetic mean here? Arithmetic mean Y bar is calculated by taking all the values, all possible values of Y, and taking their sum as y1 plus y2 plus ... yn, and that sum is being calculated by n, number of items. But here you look, Anushka, look at this particular table, that here the number of items present is 4. 4 items are present, 1, 2, 3, and 4. And therefore, the value of n has become 4. Therefore, the value of n has become 4 because there are 4 items. Okay. And with this, since there are 4 items, I have already calculated their summation. Yet I am going to show it once again. Actually, I need to calculate the sum of these items, which is 3 plus 4 plus 5 plus 6 from the y column. That means if I want to write in the according to the style given in the formula, that is your y1, that is your y2, that is your y3, and that is your y4. The entire effort of mine has been wasted. So let me write the sections once again. So capital X and yeah, are you able to see the screen? Capital X was 1, 2, 3, and 4. Capital Y was 3, 5. Sorry, that was 4. That is 5, and that is 6. And I wrote the capital XY as 3, 8, 15, and 24. And the summations were written in the following manner. The summation capital X was written as 10, the sum total of these items. How many items are there? In every column there are 4 items. How many items are there in column Y? 4 items are there. And what is the total sum of these items? That is 6 plus 4, that is 10, plus 5, 15, that is 18. And for column 3, that means this one, if I need to take the summation, that is summation xy, the value was, I think, so far as I can remember, 50 was the value. And the arithmetic mean, that means x bar, that was written in the following manner: 1 by 4, the sum total of these values, that is 1 plus 2 plus 3 plus 4, which we write as x1 plus x2 plus x3 plus x4. And we have already calculated this thing, so that is 10, and 10 by 4, that becomes 2.5. So x bar is your 2.5. And for, if I want to calculate y bar, so similarly we consider the formula for the y bar, that is 1 by 4, and the sum total of these items, 3 plus 4 plus 5 plus 6. So according to the formula, style of the formula, this can be considered as y1, this is y2, this is y3, and this is y4. And the value is 18 by 4. So 18 by 4, you can use your calculator. 18 by 4 is 9 by 2, that is, we can write it as 4.5. You can do it by yourself. If you have a calculator with you, you can use the calculator to find these values. So arithmetic mean of this distribution has been calculated. Arithmetic mean of that distribution has also been calculated. What else to be calculated? And that thing which I'm doing, you can consider this to be your step 1. In step 1, we are actually calculating. In step 1, we are actually calculating the calculation of what we are calculating? We are calculating the covariance of x and y. Covariance of xy, that is the thing which is present in the numerator. Okay, so that is the calculation which we are actually doing over here. That is the calculation. So we need to calculate the term. What was the formula of covariance? Let me write once again, because several times we have lost our screen for the connectivity problem. So the formula for covariance xy was 1 by n summation xy inside bracket minus x bar y bar. X bar y bar has been calculated. We have got our value x bar and y bar. Our x bar is 2.5. Our y bar is 4.5. We have got from this calculation. Now our job is to find this portion. Okay, so we can write it as 1 by n summation xy. This becomes 1 by n summation xy. This becomes 1 by n, the value of n is 4, and summation xy is 50 from the chart, and therefore we can calculate this to be, this becomes the value of this becomes 12.5. Okay, I shall wait, Dipanjan. Don't worry. Let me finish the problem first of all, then I'm going to take your queries. So 1 by n, this part, let me write it. 1 by n summation xy, this part becomes your 12.5. So we have calculated everything that is needed to calculate the covariance of xy. So ultimately, we can write it in the following way. Let me write it over here. So ultimately we can write that covariance of xy is equal to 1 by n summation xy, this portion which is 12.5, minus x bar is this portion, that is 2.5, into y bar, that is into 4.5. Okay, so use your calculator once again. So 2.5 into 4.5 gives you 11.25. The value is 11.25. If you have calculated, you can check. And if we subtract 11.25 from 12.5, it comes out to be 1.25. The answer is 1.25. So for the formula, what was the formula of correlation coefficient? The formula of correlation coefficient, I am again writing, it is covariance xy by sigma x into sigma y. We have got the numerator part, that is 1.25. Now we are going to find what is there in the denominator. Once we get the denominator, then we can substitute that and we can calculate the correlation coefficient between the two variables. Once this calculation is done, I am going to tell you about the relevance of this outcome, this result. And after this discussion, I am going to show this particular problem, this simple problem, by Microsoft Excel. And I'm going to show you how easy it is to calculate the correlation coefficient using Microsoft Excel. Now, the students, Dipanjan especially, can I move on to the next screen so that I can calculate the standard deviation of this, so that I can calculate these two terms? Have you copied? Can I go to the next screen? Anybody? Yes, sir. Okay. So I'm going to calculate the denominator portion now. So what is sigma x? Sigma x is known as the standard deviation of the points or values of x around, or sometimes we call it from, the mean of x. The mean of x. The detail of this particular thing will be discussed by the other teacher. I'm not going into the details of that standard deviation discussion. I'm going to talk about only how the standard deviation is calculated. Okay. I'm going to show you the technical formula only, because it is not my duty to talk about standard deviation, the relevance of standard deviation or the meaning of standard deviation. Otherwise, I shall not be able to complete the syllabus in time. But if you want my help in this regard, I can take some extra classes later on if I find time to make you understand the basics of this particular thing. Okay. So the standard deviation is actually calculated by the following formula. To calculate standard deviation, we need to calculate the variance first of all, sigma x squared, the variance. Okay. And this sigma x squared is calculated by 1 by n summation xi square, I goes from 1 to n, okay, minus x bar square. That is what is known as the variance. Okay. And for calculation of sigma x, what we take the square root of this variance term. Whatever is we obtain over here, we take the square root of that, positive square root. Why have I written plus over here? Because you see, when we take the square root of 4, we actually get plus minus 2. Okay. This means when we take the square of 2 plus 2 whole square, that is 4. When we take the minus 2 whole square, that is also 4. But when we take the square root of this quantity, then negative square root is also present, but we shall not consider the negative square root. So this point is very important. We only consider the positive square root because this is actually the measure of distance. This measures distance, and distance cannot be negative. And distance cannot be negative. So I'm going to use this particular. Similar is the case with sigma y square also. In sigma y square, we just replace x by y and we write the same formula. So we write it in the following manner. Okay, this is the formula that is, I'm going to show you in details how to calculate it. So again, for this step number 2, this is my step number 2. I'm actually calculating the standard deviations. Okay, and for this I'm going to make the chart once again. So my chart was, the values were 1, 2, 3, and 4. Y was the value of y were 3, 4, 5, and 6. And you see, we have a term like x squared. So I need to take the square of this item. I need to square the items present in x. We have a term like y squared. So I have to introduce a column like y squared. So I'm taking the squares of these terms. So 1 square becomes 1, 2 square becomes 4, 3 square becomes 9, 4 square becomes 16. And summation y square means I'm taking the square of these quantities. So 3 square becomes 9, 4 square becomes 16, 5 square becomes 25, 6 square becomes 36. Okay. And summation from this I can calculate the summation x square also. So summation x square, that means total of this column, means actually I'm taking the sum of 1 plus 4 plus 9 plus 16. This becomes, let us calculate it. So 1 plus 4 plus 9 plus 16, the total is 30. This total is 30. And summation y square, this value, this is the sum total of the items 9 plus 16 plus 25 plus 36. And let us calculate this sum. 9 plus 16 plus 25 plus 36, it is 86. The total of this is 86. So we have calculated these figures from the chart. So when we divide these quantities by the items, number of items, that is by 4, we actually get 1 by n summation. We are actually calculating this quantity. 1 by n summation y square is nothing but division of this quantity by 4. And this means when we divide 30 by 4, we get 7.5. So this quantity is 7.5. And this quantity, that is 86 by 4, this is 21.5. This is 21.5. So we have actually got our quantity 1 by n summation x square and 1 by n summation y square, which is 7.5 and 21.5. Now the value of x bar, what was the, let me write this quantity. I'm going to calculate the sigma x squared term. So in the next page, so sigma x square is given by this quantity 1 by n summation x square minus x bar whole square. Okay. And from the previous page, you have got 1 by n summation x square is 7.5. So we are going to write this over here. So this is actually your 7.5. And x bar, what was the value of x bar? The value of x bar was 2.5. So I'm going to write it over here, 2.5 whole square, because x bar is 2.5. So that becomes 7.5 minus 2.5 whole square, that is 6.25. That is 6.25. And 7.5 minus 6.25 gives you 1.25. Okay, very good. It gives you 1.25. and sigma x becomes positive square root of this 1.25. So this is actually 1.11. This is actually 1.118 approximately. The approximate value is 1.118. Similarly, we can calculate sigma y square, which is 1 by n summation y square, and that y bar square will be subtracted from it. Now the value of summation y squared is 1 by n summation y squared is 21.5. So I'm going to write 21.5 over here, and the value of y bar is 4.5. So I'm going to write 4.5 whole square. Now 21.5 minus 4.5 whole square gives you 4.5 whole square gives you 20.25, and this is actually 21.5 minus 20.25, which is actually 1.25, which is again 1.25, and sigma y thus becomes positive square root of 1.25, and that is, you know already, that is 1.118. Okay, so we have got our sigma x and sigma y. So the correlation coefficient Rxy can be written as, what was my value for covariance x? My value for covariance x was 1.25. So I'm writing it here, covariance xy by sigma x into sigma y. My covariance x was 1.25 and my sigma x was 1.118 into 1.118. So I'm going to calculate this quantity, 1.25 and 1.118 squared. This is 1.24. This is actually 1.2499. So when I divide 1.25, and you know that 1.2499 up to 2 decimal places, it is actually approximately equal to 1.25. Okay, up to 2 decimal places it is approximately equal to 1.25. So actually we have got 1.25 by 1.25, which is equal to 1. So my correlation coefficient is 1. That is my answer. This session is going to end soon. After that, you rejoin once again. Yeah, somebody, Dipanjan has got 0.992, 0.9922. 0.992 is approximately equal to 1. 0.9922 is no. If you have got 1.24, 1.24 cannot be the value. I am going to talk about this in the next session. If you have got 0.992, then it's all right. But if you have got 1.24, that cannot be. So R equals to 1 is my correlation coefficient in this particular case. This session is going to end soon, and you are going to again